Mixtures of gases. So our goal here is to be able to calculate the pressure of different gases within a mixture. All right, so to talk about mixture of gases, we have to talk about Dalton's law. Okay, so as we know that gases don't always appear by themselves, much like our air, which is a mixture of gases. Sometimes they just kind of hang around and mix together without really bonding. It just kind of exists like that. So Dalton's law refers to the pressure of gases within a mixture, saying that each gas has their own individual pressure, which we're going to call the partial pressure, and we're going to note that as P sub I. That I is going to change to represent basically whatever gas we're talking about. So, should we have a mixture of gases, naturally one would assume that the total pressure of all the gases we call P total is going to be equal to the sum of the individual partial pressures of each gas. Okay, so we can treat it as P total is equal to the partial pressure of gas 1 plus the partial pressure of gas 2 plus the partial pressure of gas 3 and so forth. Pretty easy, pretty common sense here. So let's take an example of where this might actually be used. So air, like I mentioned before, is a mixture of different gases. It contains oxygen, nitrogen, carbon dioxide, and some trace amounts of other gases. So we want to figure out what is the partial pressure of oxygen, PO2, at a total pressure of 101.3 kilopascals if the partial pressures of the remaining gases are 79.1 kPa, 0.04 kPa, and 0.94 kPa respectively. So knowing that the total pressure, P total, is going to equal to the sum of the individual partial pressures. So in this case, it's going to equal to the partial pressure of oxygen plus the partial pressure of nitrogen plus the partial pressure of carbon dioxide and the partial pressure of the trace gases here. Okay, we can figure out the partial pressure of oxygen. So we know the total pressure is 101.3 kPa. That's going to equal to the partial pressure of oxygen. Plus, now we're told the partial pressure of nitrogen is 79.1. Partial pressure of carbon dioxide is 0.04. The partial pressure of the trace gases, 0.94. Okay, you can see here all we really have to do is kind of like subtract and chip away, and we get that 21.22 kilopascals is equal to the partial pressure of oxygen. Okay, so that's Dalton's law, just basically talking about how different gases in a mixture each contribute a pressure to the total pressure.